f of g was 4 times x minus 4, or, yeah. What's going to happen here? Yeah, that 4 is canceled. It's going to be x. G of f would have been 4x over 4 when you plug g, or excuse me, f into g. I guess I did them in the backwards order. Oops. But that's still going to be x. Does anybody remember, I said the other day during the other lesson, what it means if when you compose two functions back and forth, you get x? That's right. It means they're inverses of each other. So you can put the dime away. That's it. The answers were x. But, so section 1.8. 1.8. And that's exactly what you're asked to do on this slide. You're asked to compose f of g and g of f. I'll give you a second. So we did number 1 as the DOM. What you're asked to do on all of these is compose them and then tell whether they're inverses or not. The DOM, or number 1, they would be inverses because you got x and only x, nothing else. Number 5. Let's say we did number 5. So that'd be f of g would be 5 times x plus 5 over 9 minus 9. Okay? Is anything going to cancel here? No. If my 9 and 5 had been switched, then maybe. But this is not going to cancel down to x. It's going to remain a really hideous fraction. So you can stop right there. As soon as you get that they're not just x, you can just stop and say not inverses. Exactly x. Not even negative x, not 2x, just x if they're inverses. Number 7. Let's see, that would be 3 over x plus, come on, plus, okay, now you're making me angry. Plus 4 minus 4. So what's going to happen here? The plus 4 and minus 4 are going to cancel. You're left with 3 over x, bless you, which is the same as 3 times x over 3. What's that going to equal? So far, so good. So that was f of g. Now we need g of f to see if it is also going to be x. So that would be 3 over x minus 4 plus 4. All we're doing is composing. So that's 3 times x minus 4 over 3 plus 4. The 3's are going to cancel. 3 times 3 divided by 3, leaving you with x minus 4 plus 4, which will also cancel, leaving you with x. Are they inverses? Yes. And you can just write yes or no. Yes, they are. What about number 9? Take a quick glance at number 9 and raise your hand if you think you know whether they're inverses or not. No. Well, let's see. F of g would be negative x, which is x. G of f would be negative x, which is just x. So as it turns out, negative x is its own inverse. And yes, they are. Questions from this slide? Sure. Number 3, I believe, is the one left. Number 3. F of g and g of f. So, f of g is 3 times x minus 8 over 3 plus 8. So what's going to cancel here? 3 divided by 3. So you're left with x minus 8 plus 8, which is also going to cancel. So far, so good. I've actually never seen one that only worked one way. but you never know. So g of f is going to be 3x plus 8 minus 8 plus 8 minus 8. Going to cancel. Tick, tick. I put parentheses. Whenever I plug something into another equation, I just put in parentheses so that I remember to distribute. Now, as it turns out, I'm not going to have to distribute here. But that's just my way of saying this is what I plugged in. You don't have to. So the 8's are going to cancel. You're going to be left with 3x over 3. And what's that going to reduce to, Ethan? X. Very good. And if it's x, that's right. Well, I'll tell you what. On the homework, that's up to you. However, as long as you acknowledge that on a test, should somehow they dig one up that's like that, and you assume it's yes, you accept responsibility if you're wrong. Okay. I'm not going to search that hard. If the one I pick happens to be like that, it's a fluke. Other questions? Next slide. This is basically just saying all of these are actual functions. For each function, find the inverse. Oh, these are fun. Finding the inverse of a function. It's like that Parent Trap movie where they just switch. You might be thinking, what's he talking about? Well, I'll show you. Let's look at 17. Couldn't f of x equals x cubed plus 2 also be written as y equals x cubed plus 2? They're essentially the same thing. To find an inverse, all you do is switch your variables and solve for y. So that's going to be x minus 2 equals y cubed. How do you get rid of a y cubed? Cube root of x minus 2. And that is your inverse function. Now, part B wants you to verify it by composing. Well, you just did a whole slide of doing that, so I'm not going to require that. But on your test, when they ask you to find an inverse, that's a nice handy thing to know just so you can check and see if you did it correctly. If you compose this and this, just like you did on the last slide, you should get where it filters down to x. Should. Cube root, going to cancel. So that's the way to check it, but I'm not going to require you to do that. 27 looks fun. Let's find the inverse on 20. And you know what? That's kind of a... We are going to do that one. But other than 27, is there a specific problem somebody would like to see? You can even name 4 or 5. That's fine. 19. Okay. Since it's at the bottom, I'm just going to scroll down. Whoa, no I'm not, because I apparently have more stuff down there. 19. So you switch them. That's x equals y plus 2 cubed. What's my first step here? Cube root. That's right. Then what do I do? Subtract. And that is your inverse function. Questions on that problem? Is there another one somebody would like to see worked other than 27? We'll do that one in a second. I heard 23 and 25. I'll just do both. 23. Oh, that one won't take very long. 23. I'm going to kind of just go ahead and skip the first step. So that's going to be x equals the square root of y. Adding rid of the square root. So x squared is going to be the inverse. 25. Okay. When x is in the bottom, things change a tad on what you can do algebraically. So it's going to be x equals 7 over y minus 3. What's the first thing we have to do? Add the 3. You want to isolate the y. Now what do you think we do? A lot of people will look at this and they say, why don't you divide by 7? Because then you're not solving for y, you're solving for 1 over y. So, yeah, multiply by the y. Now don't bother distributing. Just divide by the whole quantity of x plus 3. And here is your inverse. That's why I put things in parentheses, so I can remember I can just do it as parentheses. Questions on this problem? 27. This is where it gets fun. And every year, as I'm doing this one, I have a brain freeze halfway through, and it takes me a minute to remember how to do it. Hopefully that won't happen this year. Okay, so that's going to be x equals 2y plus 1 over y minus 3. Actually, yes. You're going to multiply both sides by y minus 3. Now, what you want to do now is get all the y's on one side and everything without a y on the other side. So this is going to be xy minus 3x equals 2y plus 1. I'm going to move the y's over here. So xy, and I'm going to subtract that 2y over to this side. And I'm going to add the 3x over to that side. Now what factors out of the left? Y. That's why we did that. Now what do you think we do? Divide by the x minus 2, and you're done. That's going to be a tricky one. I really hope you write that down, because that's always one that, gives people some mental brain cramp. So it would be f inverse equals 1 plus 3x over x minus 2. Yes, that's how you denote that. F negative 1 x. I think I do have more like this one actually. Let's look at another. Oh, I thought I did. I don't? Really? Yeah. Yes. Sugar. Well, I'll make one up. Let's look at maybe one more like that. Let's see. How about, well, this is going to be ugly because I'm making it up, but whatever. Absolutely. Try to find the inverse of that function. Try to find the inverse of that function. If someone feels confident, they can just do it on here while everybody else works on the paper. Who's feeling confident? All right. I'll bring it to you. What is the deal with everybody having growth? Oh, I had a car accident yesterday because I go to school. Wow, political. Oh, you have to walk up there. It's kind of hard the first time. It's going to be really messy, but by the end of the year, you're going to get tough. Wow, already looks better than mine. You're right. That looks like crap. Thank you. All I do is me meet somebody to get a light. It's hard. Well, I've only been using that thing for years. Actually, the first 3 years I taught, I actually had a smart board. Man, I wore that thing out. And then they took it away from me because I guess I never used it. How many teachers in the school, like use their marker board or their smart board like a whiteboard that write on it with markers? I don't get one. Makes me angry. So this looks perfect, so please make sure that your steps match his steps. Yes. Alright, well, the reason we're doing that is kind of an algebraic headache problem. So, I'm listening again with that multiply the total over here. There you go. Now we go to distribute the X. Now he's going to group the Y's and the X's. Did you refactor it back in? Oh no, I'm sorry. I'm lying. You did. So he's going to select all the Y's on one side and yes, that would. I'm trying to see all in your space so I don't want to block you all. That's, so go ahead and move that. Yes. Yeah, add that to over it. No, you're right. So we're ready. Good. You can't just turn it over like that. Touch this and go over everything you want to erase. First, now back to the Y out. Then you go to the other side. Now you can divide that. You're going right -7. You're solving the Y. You can divide that whole thing. And you're done. Is that what other people got? Yes, I can. May I go? Wait till I can hear you. When you come in here tomorrow, we'll have a seating chart. So just find your name on the board, and that's where you will get starting tomorrow for the rest of the week. Now, let's keep going. At this step?
Yeah.
Okay.
Well,
you just subtract it. You know how, like, if you subtract 4 from two sides of an equation, they just subtracted 3y from both sides. It canceled it here. But yeah, more or less. And then you added the 7x to this side by adding the 4 side. Yeah. Is that your only question? Yes, ma'am.
I need the step before that. How you transfer from that step to the last?
Here to here?
No.
Here to here?
Yes.
Okay. He needed to factor out a y so that he could just have a y to solve for. So he just factored a y out of this and was left with this piece. That's all he did.
Okay.
And then he divided by that whole quantity. Get that. Ma'am? Okay. Okay. Better idea. Yeah, we'll do one more. One more. But to save time, Sarah, we're just going to kind of go through it pretty quick, okay? All right. One more. There we go. Don't worry about what I'm doing. Just whenever you're done, you can compare with me. I'll try to do a better job of showing my steps this time, too. Did you have a question? Oh, good. Regret. Yeah, sorry. 1 second, Jordan. What was your question? Right here? Here we go. Thank you for that. I accidentally had a 3 on my X and it kind of carried all of the problem. Give me a Caesar verdict. How are they looking, Sarah? Where? Here? Here? We factored out a y. Now, when you factor a y out of a y, it doesn't just go away. Because if it went away, then if we multiplied back through, it wouldn't equal the same thing anymore. So it needs a placeholder. That way, if we did multiply back through, it would be 3xy minus y. Okay. Okay. Functions that are inverses of each other are symmetrical around the line. Ooh, I'm going to mess this up. Y equals x. Around the line y equals x. So, for instance, x squared, what's the inverse of x squared? The square root of x. Now, granted, we would only do the top half normally, but if you were to continue drawing the top and bottom half of x, of the square root of x, you see how those are symmetrical around the line y equals x right there? Now, here's why I'm telling you this. Normally, we care if it passes the vertical line test. But if our functions are basically going to all lay over, to see if our inverse would be a function, you can really do the horizontal line test. Because it's going to be the same picture, just turned over. So rather than drawing out the inverse of all these and then seeing if they pass the vertical line test, you can just kind of jump that step and do the horizontal line test on your original to see if your inverse will be a function. Does this one pass the horizontal line test? No, it does it twice here, 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 here. Not going to be a function. What about this one? No, it's going to touch twice or 3 times here, 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 etc. What about this one? Yes, this one will have an inverse that's a function. That one will not, and that one will not. That's right. You know, like the vertical line test, you don't want it to touch more than twice. Well, if you were to actually draw the inverses of all these, they would look similar to this one. And if you did the vertical line test, it would fail. Well, rather than draw them all out, you could just do the horizontal on the original and see if this one would have passed the vertical. So this one would be no, twice, 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 twice. No. Do four. I'm sorry, I know you guys are talking math, but it's just hard for me to talk over. You do horizontal on the first one. That way you don't have to bother doing vertical on the second. Here's the thing. Really, it's just a vertical line test to see if it's a function. But rather than draw out their inverses every time, we're just kind of skipping that step and saying, well, wouldn't that be the same thing as if we just did the horizontal on the original? Because that's what the inverse is going to be. It's going to be the exact same thing, just laid over every time. So the horizontal line test is used to see if its inverse would be a function. See, this by itself is a function, but its inverse would not be a function. Okay. Yes, sir. What? Yes, it'll always go around this line. Wherever your function is, it's going to go around that line. So if your function was over here, it'd be here. If your function like straddled this, then it would look the exact same. That's why the line, remember we did y equals negative x, it turned out to be its own inverse? That's because that, if you flip it around this line, you get like the exact same thing again. That's why it was its own inverse. So would the one you drew straddle? Yes, it would. The one I drew is almost the exact same as the top one, just flipped over. Use the graph to draw the inverse. Drawing the inverse. Now I want to say there's a simple way to do this coordinately. I don't remember what it is. So drawing an inverse, every point is going to have a counterpoint on the opposite side of the axis. So this one's going to be here. This one's going to be here. This one's going to be here. Connect the dots. Ish. And there would be the inverse of that function. Now, again, I'm pretty sure, what is this point? This is point 3, 2. This is point 2, 3. Yeah, I'm pretty sure a quick way to do that, if you want to just do it with coordinates, if you just flip your coordinates, then you're going to get the coordinates of your inverse. 3, 2 on your inverse is going to be the point 2, 3. 2, 0 on your inverse is going to be 0, 2. 0, negative 4 is going to be negative 4, 0. So a quick way to sketch these is find some coordinates, flip them. Just perfectly flip them. And if it's a point like 1, 1, well, that means your point is going to be the same on both sides. Questions about sketching these things? Okay. Yep. Here, all you have to do, find the inverse, and then graph the original. Yeah, you know what? That's where we'll start tomorrow. That's where we'll start tomorrow. We'll finish this up tomorrow. This is kind of a long lesson. Yes.